Alrighty, we are back with one more video on how to find the equation of a parabola given the x-intercept and the y and some other point. In this case, it happens to be the y-intercept. So you might notice one thing weird on this one is that it only has one x-intercept, and the only way that could actually happen is if that has only one x-intercept. And the only way that can happen is if that x-intercept is also the vertex. So that is actually what is going on here. So we have our x-intercept, but there's only one, and it's at -5. So, well, we'll go through this similar process that we did at the end of the last video. And so our factored form, remember, is f of x is a times something and something. Well, again, I know that when I plug in f of -5, you're going to get 0. So that must mean that one of these pieces has to equal 0. Well, a itself is just going to be a number like 2 or 7 or whatever. So a itself is never equal to 0. Never equal to 0. And so what piece could I go in here? Could I put in there to make sure that it's going to be equal to 0? Well, one of the pieces would have to be, so I'll leave that one, like so, would have to end up being, well, -5 minus 5. Sorry, -5 minus -5. Right? And so what's the deal here? Well, this was x, and this part right here was x. Alrighty? And so what I can say is that 0 is equal to a times something times x minus -5, so it would be x plus 5. I don't want to say, so you might notice like, well, if that's x, like this was also x, so why didn't you replace that one with x? Because if I did that, we would just have x minus x, and your function would just be a 0 equals a times 0, which doesn't tell you anything, right? It's not a helpful graph anymore. Okay. So here's our function so far, and the question is like, well, what about the other piece? And that's a good question. Well, first off, does there even have to be another piece? Could I just write it as, oops, sorry, not 0 there, f of x? Could I just leave it like this? F of x is equal to a, sum of a, which we'll find, x plus 5. That's tempting to do, but it actually won't work. And why is that? Well, remember, what makes this graph a parabola is that it has an x squared term in it. And so if I just leave it right here, this wouldn't be a quadratic function anymore. It would be a linear function. So unfortunately, we do need to figure out what this is. Okay, so what is it? Well, I can't just like make up something, because if I just add in, say, oh, I'll just make it, x minus 2. Well, that would mean that it has another x-intercept, that positive 2, but it doesn't. It has only one x-intercept. The way we can think about this, though, is that it does have two x-intercepts. It's just instead of being, say, over here and over here, they're actually just sitting on top of each other. This is actually how you're going to want to think about this when you think about higher degree polynomials in future classes as well. Is that there are two x-intercepts, they just happen to be in the same location. And so instead of just saying at -5, I can say there's one at -5, and the second one is also at -5. And it sounds kind of weird, but what that lets us do is then repeat the process right here and say our function is going to be x plus 5 times x plus 5. And so now we have our correct solution, because if I wanted to ask you, hey, where are the x-intercepts for this function, you would say, okay, well, this equals 0 when x equals -5, and this equals 0 at -5. And so really, well, there's only one answer, -5, and that's where the one x-intercept is. You know, it's almost like double counted, but that's okay. So our function actually can be written like this: a times x plus 5 squared. So whenever you get a perfect square, or sorry, whenever you get a factored form where the two factors are exactly the same, it turns out that that one x-intercept that it produces is also the vertex. But let's move on now, and let's actually find what a is, and we can do that by using that point right there, excuse me. So f of 0 is equal to negative 50, and that's going to be equal to a times 0 plus 5 squared. So 0 plus 5 is 25, so 50 is equal to 25a, and if I divide both sides by 25, lets me say that a is equal to negative 2, it looks like. So our actual equation is f of x is equal to negative 2 x plus 5 squared. Now, if I wanted to get this into standard form, because you totally can, we'll do that. Just remember our order of operations. So we'll do our exponent first. So x plus 5 times x plus 5 leaves you with this. X squared plus 10x plus 25. And then when I distribute that negative 2, I'll get negative 2x squared minus 20x minus 50. And we can double check. Remember that minus 50, because it's our constant term, should be our y-intercept, which it is, as we can see here. So that's how we can use the x-intercepts. Again, this was an interesting case because the x-intercepts, the two x-intercepts are actually only one x-intercept, plus a third point, or I guess in this case it was actually only a second point, to get the equation. So thanks for watching, and I hope you feel better now about turning the graph of a parabola into the equation. I'll see you next time.